Hearty welcome to all of you. Today we will discuss some important topics of electrostatics. As you all know, electrostatics is the branch of physics which deals with the mechanics of static charges. We know charges are two types: positive charges and negative charges. Negative charges. Some of the properties of the charges are the like charges repels and like charges attracts. In an isolated system, sum of total charge remains constant, whatever changes takes place in that system. And charge of a body or a particle is always an integral multiple of the fundamental unit of charge. We are taking that Q is the total charge, and then Q is equal to Ne, where N becomes 1, 2, 3. Okay, E is the charge of the electron, and that is 1.6 into 10 raised to minus 19 coulomb. Coulomb is the unit of charge. So another important property is charges at rest produces electric field around itself. A charge moving with uniform velocity produces electric field and magnetic field. So that means the charge moving with velocity produces electric field and magnetic field. And another important property, accelerated charges emit electromagnetic radiations. And another important equations are the line charge lambda is equal to line charge density lambda is equal to Q by L. If it is surface charge angle, that becomes sigma, that is Q by A, where A is the area, and if it is volume charge, rho, the charge density is rho, then that rho is equal to Q by V, the volume. So the most important law in electrostatics, that is Coulomb's law. So we already know what is Coulomb's law. If there exists two charges, Q1 and Q2, there is always a force between them, and that force is proportional to the magnitude of the charges Q1 and Q2 and inversely proportional to the square of the distance between them. And we can write as F is equal to K into Q1 Q2 divided by R square, where K is known as Coulomb constant, and that value is 1 by 4 pi epsilon 0, where epsilon 0 is the permittivity of free space. And its value is 8.854 into 10 raised to minus 12 Coulomb square, Newton inverse, meter square, meter raised to minus 2. This law is valid only for point charges, and this is since we know that force is a vector quantity, the Coulomb force is also a vector force, and this is the vector representation of Coulomb's law. So this is the force on Q2 due to Q1, okay? And similarly, a force is existing on Q1 due to Q2. And if Q1 becomes 1 by 4 pi epsilon 0, Q1 Q2 divided by R21 square into R21. So its magnitude, so when we are comparing that, we will get that F21 is equal to minus of F12. F12, this is F21 is equal to minus of F12. There is a correction. So next, we will discuss some topics based on this electrostatics. So we have to consider how many electrons must be removed from a piece of metal to get a positive charge of 1 into 10 raised to minus 7 coulomb. So how many electrons must be removed from a piece of metal to get a positive charge of 1 into 10 raised to minus 7 coulomb. So here we are using the concept of charge conservation. Okay. So we know that the total charge in a system Q is equal to Ne, where N is the number of charges and E is the charge of a positive, okay, for getting a positive charge. So for getting the positive charges of 1 into 10 raised to minus 7 coulomb, we have to consider the total charges present in the system. So at the end, it is given that the total charges present in the system is 1 into 10 raised to minus 7. And that is equal to, we know, n into E, where n is the number of charge. And we know that E is the charge of the electron. So that is 1.6 into 10 raised to minus 19. Okay. So the number of electrons must be removed from this piece of metal is n is equal to 1 into 10 raised to minus 7 divided by 1.6 into 10 raised to minus 19. Okay. So that becomes 1 divided by 1.6. This 10 raised to minus 19 will move on to the upper side. So that becomes 1 by 1.6. We will get 0.625 into 10 raised to 12. 0.625 into 10 raised to 12. So looking into the options, we will get the number of electrons that must be removed from the metal is 6.25 into 10 raised to 11. So the answer is option C. Next question. Two small balls, each having plus Q charges, are connected by a non-conducting wire of length L. Calculate the tension in the wire. So read the question and try to make a diagram of this question. So it is given that the two small balls, each having charge plus Q. Charge plus Q connected by a non-conducting wire of length L. This is the length of the wire that is connected by these two balls. Calculate the tension in the wire. We know that two small balls having charge plus Q. So since there is a charge existing between these two charges, these two balls, there is a force between these two charged balls. So that is, since both are having plus Q charges, the force will be force of repulsion, because we know that like charges repel each other. So the Coulomb force, there exists the Coulomb force, and that Coulomb force, we know that F is equal to K into Coulomb constant K into Q divided by the separation between them, that is L square. So that is equal to K Q square divided by L square. So this is, we have to calculate, this is the force existing between that two wire, and that is equal to the tension of the wire. So we can say that the tension T is equal to this F. Therefore, the tension of the wire T is equal to K Q square by L square. So the answer is option A. So next question. If a point charge Q is placed at the center of a cube, then the outflux through any one face of the cube. Okay, we have to find out the flux coming out of any one of the face of this cube. This is the cube we have considered, and a charge plus Q. It's given a charge plus Q is placed in the inside this cube, and it is given that some flux is coming out of this cube. We have to find out the total flux coming out of any one of the face. We know that the total flux coming out is equal to total charge enclosed. Okay, the total flux coming out is equal to total charge enclosed. So the total flux coming out, fly out total. Total will be Q by epsilon 0, that we know. Okay, charge enclosed is flux total charge. Okay, here the total flux coming out is equal to total charge enclosed divided by epsilon 0. So this becomes phi out is equal to Q by epsilon 0. So here it is. We need the total flux coming out, not the total flux, the flux coming out any one of the phase. We know that for a cube it has 6 phases. So the flux coming out of any one of the phase becomes phi out from phase. Okay, it's equal to Q divided by 6 phases are there. So the flux coming out is 6 epsilon 0. So the answer is Q by 6 epsilon 0. That is option D. Two particles of equal mass m and charge q are placed at a distance of 16 centimeter. They do not experience any force. The value of q by m is. We have to find out the value or the ratio of q by m. So it is given that the two particles of mass m and charge q are placed at a distance. So we can consider this is the mass of the body, having two particles having mass m and charge q. And charge q are placed at a distance of 16 centimeter apart. The distance between them is 16. They are not experiencing any force. We know that if there is two charged particles, they are experiencing a force that is known as the Coulomb force. So the Coulomb force between these two charges is F Coulomb. So we can FC, and that is equal to 1 by 4 pi epsilon 0 q square divided by the distance between them. Okay, so that is 16 into 10 raised to minus 12, because centimeter we are converting that into meter. Minus 2, 16 into minus 2. 1 by 4 pi epsilon 0 q square divided by 16 into 10 raised to minus 2 square. Okay, this is the Coulomb force existing between these two masses. And also we know that there is a force of gravitation is existing between these two particles, and that is Fg, force of gravitation, and that is equal to Gm square divided by r square, that is the distance between them. So that becomes Gm square divided by 16 into 10 raised to minus 2 square. So it is given that there is no forces experiencing between them. That means Fg and Fe are balancing. That is Fg is equal to Fe, or Coulomb force. So it's given in our problem. So we are getting that Fg is equal to Gm square divided by 16 into 10 raised to minus 2 square, that is equal to 1 by 4 pi epsilon 0 q square divided by 16 into 10 raised to minus 2 square. Okay, so this common factors we can cancel, so we are getting that Gm square is equal to 1 by 4 pi epsilon 0 q square. So we need q by m. Therefore, q by m square is equal to 4 pi epsilon 0 into g. So therefore, we are getting that q by m equal to square root of 4 pi epsilon 0 g. So the correct answer is option B. So now we will move on to next question. Okay. There are 3 point charges 4q, q and capital Q and Q are placed in a straight line of length L at points 0, L by 2 and L respectively. The net force on the charge Q is 0. Then the value of Q is. So first we will try to make a diagram of this question. So we have, it is given that 3 charges are placed. The value, the point charges 4q, then q, then small q of straight in straight line of length L at points 0, L by 2 and L respectively. So we have to draw this accordingly. So it is given that if they are placed at 4q, center capital Q. So this distance is L by 2 and this is also the total distance is L. Okay. The net force on the charge Q is 0. The value of capital Q. So it is given that the net force on Q is 0. That is, the force on this charge, force, the net force, F net on this equal to 0. So from Coulomb's law, we know that there existing some force on Q due to the presence of these 2 charges. Okay, so that we can write it as F1 is the force due to force on Q, F1, force on Q due to 4Q, and F2 is the force on Q due to capital Q. So what is the value of F1? F1 will be equal to this one, K into that one by Coulomb's constant K is equal to K into 4Q into Q divided by the separation between them is L square, and F2 is equal to K into capital Q into small q divided by distance between Q and this one is L by 2. So that becomes L by 2 square. So that becomes K into 4Q divided by L square. Okay. So the net force on this Q is 0. That means F1 plus F2 is equal to 0. F1 plus F2 is equal to 0. So we are getting that 4K Q square divided by L square plus 4K K capital Q small q divided by L square, that is equal to 0. Common factors we can cancel. We are getting that 4q square plus 4q into small q is equal to 0. And this 4 also cancel, q also cancel. We are getting that q is equal to minus q. Okay. Therefore, the answer is q is equal to minus q. Okay. So these are the some types of questions that are frequently asked for your entrance examination. Please do more problems like this. Thank you.